Okay, hi guys. So today we're going to be working on Chapter 2, Lesson 1. So Chapter 2, Lesson 1. This is going to be rational coefficients. So remember we talked about what a coefficient was. A coefficient is the number in front of a letter. So in order to work with rational coefficients, we need to work on a couple of things. First, rational means any number that can be made into a fraction. So if we have, say, 1/5 or 2/9 or 4 1/6 or even 3 whole number can be made into a fraction. So you're going to be using coefficients, which is the number in front of the letter, and it's going to be in a single form of either a fraction, a decimal, mixed number, or a whole number. You need to remember what a multiplicative inverse is. So a multiplicative inverse, you did this in your definitions, would be a number flipped over. So if you had 2, then it would be, which is 2 over 1. So the multiplicative inverse would be 1/2. If you had, say, 2/5, then the multiplicative inverse would be 5 over 2. If you had -3/9, then the multiplicative inverse would be -9 over 3. So the sign has to stay the same and you flip it over, okay? When you multiply them together, they will equal 1. So -3 times -9 would be +27, and 9 times 3 would be 27, and 27 over 27 equals 1. Again, here it would be 10 over 10, and here it would be 2 over 2, which equals 1. So again, each one of the multiplicative inverse has to equal 1 when you multiply them together. A reminder on how to change mixed numbers into improper fractions. So say you have 3 2/3. To do this, you're going to multiply the whole number times the denominator. So 3 times 3 is 9, and then you add the numerator. So that would be 9 plus 2, which would be 11 over 3. So try another one. So if we had 4 2/5, we would multiply 5 times 4. 5 times 4 is 20, and then we would add the 2, so we would get 22 over 5. So multiply the denominator and the whole number, add the numerator. How do we know that's right? 5 goes into 20 4 times with 2 left over. 3 goes into 11 3 times with 2 left over. This is how we get our improper fractions. So if you have a variable and you're solving for the variable, I only want to know what one value of the variable is. So if the number in front of the letter, the coefficient, is a fraction, that means I've only got 1/5 of the value of x. I want the value of x. So if I told you 1/5 x equals 12, to get rid of this 1/5, I have to multiply it by its multiplicative inverse. So I would multiply by 5 over 1. The 5's are going to cancel, the 1's are going to cancel, and that leaves me simply with the x, which is what I want. Because 5 times 1 is 5, 1 times 5 is 5, 5 over 5 equals 1. I have 1 times x, I have x. In this case, you're going to multiply 5 times 12, and that's going to give you 60 over 1, or just 60. How do I know this is right? Because if I go back to my original equation, and I take my 1/5 times x, 5 goes into 60 12 times. 12 times 1 equals 12, which is what I said. I can check my work, and I know I'm right because the math works out. You should never wonder if your answer is correct. Go back and check. Let's try that again. Say you have -2 over 9d, and that equals 4. The multiplicative inverse is -9 over 2. Again, you must do the same thing on both sides of the equation. You've got to keep it balanced. Add something here, you got to add the equal amount over here. Multiply here, equal amount multiplied over here. So the 2 cancels the 2, the 9 cancels the 9, the negatives cancel each other, and again, we are left just with our variable. So over here, you can multiply 4 times 9 and then divide by 2, or you can cross cancel. 2 goes into 4 2 times. 2 times negative 9 is negative 18. So we'll check our work. 2 ninths times negative 18. 9 goes into, sorry, this was negative 2 ninths. 9 goes into 18 2 times, and we have our negative here, so negative 2 times negative 2 equals 4, and that's where we started. So our answer checks. We don't have to wonder if we got it right. All right, what if you've got something that looks like this? 4 and 1/6 equals 3 and 1/3 C. First thing you're going to do is convert this to improper fractions. So 4 times 6 is 24 plus 1. So this would be 25 over 6. 3 times 3 is 9 plus 1 is 10. So this would be 10/3 C. The number in front of the letter is 10 over 3. We're going to multiply by its inverse, which is 3 over 10. On this side, 3 over 10. So cancel, 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 and I'm left with C on this side. Now on this side, you can multiply 6 times 10 and 3 times 25, or we can just factor. So we have 3 times 5 times 5, because 25 is 5 times 5. Here we have 2 times 5, and here we have 2 times 3. Why did I do this? So I can cancel easier. 3 cancels 3, 5 cancels 5. We're left with 5 on top, and 2 times 2, which is 4 on bottom, and that's your answer. Now you can leave it as an improper fraction, that's fine, or you can change it to a mixed number, and that would be 1 and 1/4 to be what C is. So let's find out if that's going to work. If I come back up here to the original problem, and I put in here 5 over 4, and I'm going to multiply, change this to the 10 over 3. That's going to give me 50 over 12, and that means I'm going to have 5 times 2, and on bottom I'm going to have 6 times 2. The 2's are going to cancel. I'm going to have 25 divided by 6. 6 goes into 25 4 times with 1 left over, so it would be 4 and 1/6, which is what we started with. Our answer checks, so we know our answer is correct. What if we were doing it and it was decimal? So you have 4.9 equals 0.7 t. I like to have my variable on this side, so I'm going to move that 0.7 t to this side. I didn't change the problem, I just flipped it over. The number in front of the letter is 0.7, so I'm going to divide both sides by that because that's a multiply, and the opposite of multiply is to divide. So this is going to be t because this is going to cancel. I'm going to move the decimal over one place on each, top and bottom. I did the same amount on top and on bottom. This means I'm going to take 49 and divide it by 7, and that is 7. So if I take 7 and I multiply 7 times 0.7, 7 times 7 is 49. I move the decimal one place out, one place in. So this would give me 4.9. Check. That's where I started. Okay? You're going to learn 9 little words. The 9 little words that you're going to learn are divide by the number in front of the letter. 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the 9 little words. When I tell you to solve a problem using the 9 little words, you need to know what those 9 little words are. Divide by the number in front of the letter. We're going to say it so many times, it's going to become a song in your head. But it is a very, very important 9 little words, okay? Divide by the number in front of the letter. So when you are doing your work for me, which is posted on the Google Classroom, please note half credit comes from showing your work. You turn in the assignment with no work shown, you lose half credit right off the bat. So do your work on a separate piece of paper. Do it on a whiteboard. Do it however you want, but I need to see each step you're taking in order for you to receive credit. Getting the right answer isn't always the most important thing. Sometimes it's the process. And I cannot see where your answers are incorrect if you do not show me your work. So please remember to show your work. All right. Hope this helped. Bye.